So the tan graph. We've seen what sine and cosine look like, very similar to each other. Okay, just one's shifted horizontally away from the other. We call those periodic functions because they repeat the same pattern after a certain period. And we also call them sinusoidal because they follow like a wave-like pattern. Okay. Tan is periodic. It will follow a certain shape over and over again over a certain period, but it's not sinusoidal. It's not wave-like. And we're going to see that right now. Remember, and again, we'll do a table of values. And this is good to know. This is good practice learning or remembering your unit circle. Remember, tan is the y coordinate on the unit circle divided the x coordinate. So remember, just to sort of start off, the point on the unit circle at 0 radians is 1, 0. The point on the circle at pi over 4, because that's relatively easy to find, is root 2 over 2, comma root 2 over 2. Pi over 2, or 90 degrees, is 0, 1. Three pi over 4 is negative root 2 over 2, comma root 2 over 2. Pi is negative 1, 0, and then it continues from there. So 5 pi over 4, they're both negative, the root 2 over 2's. 3 pi over 2 is 0, negative 1. 7 pi over 4 is root 2 over 2, comma negative root 2 over 2. And 2 pi goes back to 1, 0, because it completes a full revolution or complete circle. Well, y divided x. What's 0 divided 1? 0. This divides itself. Sorry? 1. 1 divides 0. Undefined. I'm going to grab that. This divide this. Negative 1. This divide this. 0. And then we've got, this is actually going to be positive 1 because it's negative root 2 divide negative root, sorry, negative root 2 over 2 divide negative root 2 over 2. This is going to be undefined again. 1. Negative 1 divided 0 is undefined. This is going to be negative 1. This is going to be 0. Notice that it completes the cycle a little bit sooner. We actually put in 2 cycles, didn't we? Because it went 0, 1, undefined, negative 1, back to 0. 0, 1, undefined, negative 1, back to 0. So we got to show that. So I need, everyone is going to be pi over 4. So put some notches out here. This is going to be pi over 4. This is 2 pi over 4, which is pi over 2. This is pi. This is 3 pi over 4. Oh, sorry. Made a mistake. 1 pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4, which is 5. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4, which is 2 pi. So, And on the vertical axis, it's going to be 0, 1, or -1. So I'm just going to put 1 up here, or undefined. Okay, so let's put this in. 0 is 0. Pi over 4 is 1. Pi over 2 is not defined, so there's no point here. We'll talk about that in a second. 3 pi over 4 goes to -1. Pi goes to 0. 5 pi over 4 goes to 1, and now we're undefined again. 7 pi over 4, -1. 2 pi is 0. Well, remember, we go from here to here, so it's going to be something. But I don't know if it's a curve. I don't know if it's a straight line. I'm not sure. Like, it almost looks like you can go like this. However, there's that pi over 2 and 3 pi over 2, where it's undefined. That means the graph doesn't go there. It can't cross there. It's like a barrier. It's like a barrier here. And it's like a barrier here. We can go close to that. We just can't cross it because they're undefined. Do you remember what those are called? Vertical asymptote, which we will revisit a little bit later on more frequently. But an asymptote is a line that a curve approaches but never touches. So it's almost going like this. If I go from here to the asymptote, it's going to go like that. It's going to go like that. It's not going to touch it. It's going to go, it's almost skirting right alongside it. If I go backwards, it's going to go like this. And like this. So what it is, it's kind of a stretched out S shape almost. You're taking an S and stretching it right out. So it would follow the same pattern here. And it would follow the same pattern here. So you can see it's periodic. It takes this shape. And then it hits an asymptote, so it's got to jump over it and start its shape again. So it looks a little bit different. And just to look at some of the properties. Well, what's the amplitude? Well, I guess we could say that this is the midline, right? This would split it in 2 equal pieces, a horizontal. So it goes from the midline to the maximum. It's the amplitude. What's the maximum? Sorry? Yeah, there isn't one. It keeps going, look at those arrows. It keeps going up forever. And it keeps going, oh. And it keeps going down forever. So there's none. There's no amplitude. How long horizontally does it take to complete a cycle? Well, we can see a complete cycle here. So it started at pi over 2, and then it went 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is the same as pi, right? So a cycle, remember, a cycle, it starts its pattern again after pi. So the period, it's not 2 pi like sine and cos, it's pi. What would the domain be? Can we say negative infinity to positive infinity? No, because we can't include these. So, and there's infinite number of these vertical asymptotes, which means we got to use that K thing somehow. Well, where do we see the first asymptote? At pi over 2. And then it occurs after pi. So pi over 2, if I add a pi, I get to here. If I add a pi, I get to another one. If I start here and subtract a pi, I get to another asymptote. Here I get to another asymptote. So how do I show adding positives and adding negatives forever? K, where K is an integer. So this is going to be pi over 2 plus pi K, where K is an integer. But that's where the domain isn't, right? Those are all the vertical asymptotes. So X can be anything as long as it's not these. So how do I write that? X cannot be this. X, if you think of a notation for cannot be, an equal sign. That's the best way we can write the domain. We can't, because then otherwise we'd be writing, okay, it's from here to here, and then it's from here to here, and then it's from here to here, and you're going on forever. It's impossible to write. So what we do is we write what it cannot be. What would the range be, lowest to highest? Lowest to highest. Negative infinity to positive infinity. It doesn't have any horizontal barriers. It goes down forever and it connects to go up forever. The y-intercept, 0. And the zeros was like, or it's like what we did with sine and cosine. Zeros are occurring every pi. So it's 0 pi, 2 pi, and 3 pi, and 4 pi. If we went the other way, it'd be negative 1 pi, negative 2 pi, negative 3 pi. So how do I write plus 1, plus 2, plus 3, plus negative 1, plus negative 2? I write K, where K is an integer. So the zeros are going to be pi, that's 1, plus every pi K, 1, 2, 3, negative 1, negative 2, negative 3, where K is an integer. Okay. See it. So that's what the tan graph looks like. So just a couple of things, like there is a y-intercept, there's no amplitude, okay? Doesn't cover every point in the domain because of those vertical asymptotes. Again, exam-wise, you'd see a 1 marker. I've seen a question that says, which of the following is the tan graph? And then it gives you 4 different graphs. And then you get some multiple choice. Okay,